Question 7. This one. It is from June 2012 and it will be variant 2. All the worksheets are from variant 2. Okay, so see, it is 9 marks question and the second part is 4 mark question. So 13 marks are from this question only. So the friction force acting on a small block of mass 0.15 kilogram. So the mass is 0.15 kg. While it is moving on the horizontal surface has magnitude this. The force of friction is 0.12 Newton. Okay, so the block set in motion from a point X on the surface with speed 3 meters per second, and it's already given in the question diagram. It hits the vertical wall at the point Y, so it is going here and hitting the wall. So it is hitting the wall. I will draw it here. So 2 seconds later, so t is equal to 2 seconds from here to x to y. So from x to y, time is 2 seconds and initial speed is 3 meters per second. So the block rebounds from the wall and moves directly towards x before coming to rest at the point z. So after hitting the wall, it is rebounded and it is going in this direction, so towards x. But it will not reach here due to the friction. It will stop at the point z. So at z the speed is 0 meters per second. Okay. So 2 stages of motion. One is from x to y and the second one is from y to z. From y to z we don't know the speed at y. But we know the speed at z, that the final speed is 0. Okay, and the speed at y while hitting the wall and while leaving the wall, it's not same, because in the next sentence they are saying that. At the instant that the block hits the wall, it loses this much kinetic energy. When the kinetic energy is lost, so the speed will decrease. Okay. It means the speed is not same while approaching y and while leaving y, the wall. Okay, so the velocity of the block in the direction from x to y is v meters per second in time t second after it leaves x. So this information they gave because they also asked us to sketch the velocity time graph. The velocity we are taking from x to y positively. Okay. So find the value of v. So there are many parts in this question. So first part is that find the value of v when the block arrives at y. So this is, let's say this is the first part. To find the speed by which it will hit y, the ball. In this stage, so we have to find the value of v. Okay, we don't know a, so first we will find a. Because the friction is given. Okay, this wording which they used, the block is set in motion from the point x with the speed 3 meter. It means this is the situation like it may be hit by some force and then after that it is moving by itself. Okay, so it means that there is no forward force. So this point is important. So forward force is 0. And the backward force is 0.12 and that is equal to the mass times the acceleration. So this is giving us the value of a. That will be negative 12 over 15, so which means it will be 4 over 5. Okay, so automatically see we got the deceleration.
Master, can you repeat the part about the forward force? Why is it 0?
Because there is no forward force given to the object. It is not being pushed by some force or not being pulled by some force. They are saying that the object is set in motion at point x with a speed of 3 meters per second. So this means that it is hit by something, or it is projected by a speed of 3 meters per second towards y. So this means there is no driving force after when it begins to move. Before begin to move, maybe there is some force, the hitting force. So we are considering such situation before also in that chapter 3, 4, 5. Hitting, projecting means no forward forces, right? Is it clear? Forward force minus backward force is equal to ma. We are applying, and we got this. So now that means the speed we can easily find. V is equal to, because the time is there, so u plus at. So u is 3 and minus 4 over 5 times 2. So what we will get? 4 minus 8 over 5. 15 minus 7 over 5.
7 over 5, sir.
So 7 over 5 meters per second. This is the answer of the first part. This is the answer of A. Okay, then, and when it leaves Y, now this is part B. When it will leave the wall Y, so there is a loss of kinetic energy here, so we'll use the delta KE here. So part B, since they said that the delta KE is equal to minus 0.072 because it's a loss, so it will be minus 0.02. Okay, this one. So what is the change in kinetic energy? That is half m into v square, which we need to find, and it is hitting the wall with a speed of 7 over 5. So this is u square, right? And that is equal to minus 0.072. So from this equation you can find the value of V. So V square minus 49 over 25 is equal to, we take this quantity to the other side, 0.072 times 2 divided by 0.15. So it is 24 over 25. So negative 24 over 25. And this one will be moved there, so it will be V square is equal to 49 minus 24 over 25. You can use calculator. So it's 1.
Yes, sir.
So it means V is equal to 1 meters per second. So this V is the initial speed from Y to Z. So this is part B. Part B means while leaving Y. And this is while hitting Y. Two different speeds, and this speed should be smaller than that because there is a loss in the kinetic energy. So this question basically we can also do by using the law of conservation of momentum. Okay, so later our topic is that this is a wall and this object is coming towards the wall by some speed, and after hitting it will go away from the wall. So we take one object, the object, and the second object, the wall. So initial momentum of both will be equal to the final momentum of both. Since the speed of wall will be 0 in both cases, that's why we will have only one object. So by that method we can also use this. Okay, but we will, since in 2012 in our syllabus we were not having the momentum, at that time we are doing it by using the work energy chapter. Now if they ask, we can do by that. Okay. So this is clear, part B. Still the question is not complete. Find also the value of the t when the block comes to rest at Z. The value of t, what is t actually? T is the time when it leaves point X. See this one. So it means 2 seconds already plus the time it takes from Y to Z. This is the question. So it is part C, we mark it part C. This one is part C. Find also the value of t. So for C, it is basically going from X to Y and then phi to Z. So first stage is t is equal to 2. Second stage we have to find, and it's easy because from Y to Z, initial speed we already got, it is 1 meters per second, and at Z the final speed will be 0. It's given in the question statement. And deceleration will be same because it's the same object and same surface. So the friction which is in the forward direction, that will be when it is coming back, the friction will be same. The acceleration will be minus 4 over 5. 5 over 4 or 4 over 5? 4 over 5. This one. Okay? So now the time will be v is equal to v plus at. So 0 is equal to 1 minus 4 over 5 t. So t is equal to 5 over 4, which is 1.25 seconds. So therefore the required time which they are asking to find, that is actually from point X till reaching to the Z. So that will be equal to 2 plus 1.5. So some student gave the answer only 1.25. That will be wrong.
Sir, why do you
Take the same acceleration, so then find the acceleration. It is moving in this direction. The forward force is 0 and the backward force is the friction force. So you will get the same value. Right? 0.12.
Okay, I got it, thank you.
So basically remember to save your time in the exam, if they are asking the same surface and same object, so the friction will be same if they don't change any other thing. Okay, so this will be minus 4 over 5. So we are taking the same deceleration. So this is part C, and then the last part of this question is that we have to sketch the velocity time graph. So many students do mistake while sketching this graph. In the next part they will ask displacement time graph. Here they are asking the velocity time graph. So according to the motion, they said that v meters per second is going towards this side. It means in this direction it will be then minus v. 2 seconds in the forward journey and 1.25 seconds in the reverse journey, right? So now you can easily sketch. Initial speed was 3. So initially it will start with the speed of 3 meters per second, then deceleration, but will not reach to 0, straight line, till by what speed it will hit the wall? What was the speed? 7 over 5. In decimal it is 1.4. Right? So here in 2 seconds, this speed will be 1.4. Till here it's clear?
Yes, sir.
Okay, now you will tell me, all the students, that what will be the next stage, where we will draw the next stage. Next stage is that initial speed is 1 and the final speed is 0, 3.5. or 3.1 or 3.25 this time. Okay, so where we will show velocity is changing from -1 to 0, because this direction we are taking negative v, this direction positive v. So where is the velocity -1? -1 will be here, right? So at 2 it is -1 and then it will be 0. So this vertical line means nothing. This is actually the hitting time with the wall. Hitting instant, not the time, because it's not taking any time while hitting and leaving the wall. We are assuming that it's not taking any time, because we cannot find that time, that how much time it will take to hit and go back. So mostly in physics and mechanics, both we consider that time approximately 0. So this is the velocity time graph. It was simple, I don't know why you didn't know. So now this one, the displacement of the block from point X, the displacement they are taking from the reference point X. So again the same, that it is going towards the wall and then coming back from the wall, reaching to the point Z. Okay, so in the direction from X to Y is S meters in time t second. So as a displacement time graph, show on your graph the value of S and the t when the block is at Y and when it comes to rest at Z. It means that we need to first calculate the distances. Otherwise, usually when they ask to sketch, we don't do further calculations. But since they said that also show these values there, it means we'll find the distance from X to Z, Y, and then Y to Z, which is very simple. You can use either S is equal to ut plus half h square, because we have the time. So if this distance is S1, this distance is S2. So S1 will be equal to ut plus half h square. So u is 3, time is 2, plus half into deceleration is -4/5 into 2 square. So what you are getting, can you calculate this? And then we will also calculate S2. S2 initial speed is 1 into time is 1.25 plus half into -4/5 into 1.25 square. And okay, so this one, sorry, meters, not meter per second. And the second one, 0.625, right? It means that it has moved forward 4.4 meters and then came back 0.625 meters. So then the remaining, the displacement of Z will be, the displacement will be from the reference point. So displacement of Y is 4.4 and displacement of Z will be 4.4 minus 0.625. Okay, so that will be 3.775. Okay, so the calculation part we have done, like the displacement of of Y is 4.4 and the displacement of Z is 3.775. So now we have to sketch the graph. So since it started from point X, so it will start from the origin. To start from the origin. So forward motion I'm taking as green and the backward motion I'm taking as blue. Okay. So this part is green. So what will be the curve? By the acceleration and deceleration are curves, right? So what is the acceleration curve in the forward direction? Sorry, deceleration curve in the forward direction. Do you remember? Or?
Yes, sir. It's concave up.
Concave up. No, it's deceleration. It will be concave down.
So I don't know the name, but it's like a U. Not a U, but it's...
Okay, I will draw 4 shapes. You will tell me which one is that. 1, 2, 3.
So the first one is acceleration.
3 and 4. This is 1, 2, 3, 4. Which one?
1 is acceleration forward.
Here, which curve we will draw for the first stage of motion? 1, 2, 3, or 4?
1.
Okay. 1 is acceleration. It is decelerating.
Oh, okay. So it's 2.
It's 2. Okay, correct. So keeping in mind that because the final speed is not 0, so we will try to not make the final curve as horizontal. Like we will not do it till here like this. Okay, because it didn't come to rest. It reaches to the speed of 1.4. So avoid this horizontal part. So we'll draw it till here, right? So this one is 2 seconds. How much? What is the displacement? Yes. I think you are tired, all of you. Okay, so after that, immediately it starts, again it is decelerating, but in the opposite direction. So which curve of these 4 is the deceleration in the backward direction?
The third one.
No, 1 is the forward.
No, third one.
Third one, okay. Forward, and this is backward motion. So 3 is the deceleration. This is acceleration. So remember these, you will not forget these. So this is acceleration in the forward, this is deceleration in the forward, and this is deceleration in the backward. So this curve we will draw, and finally it is coming to rest. So here, and with blue color I am drawing the backward. So it will go down and will reach to the 0 or not?
No.
No, so we'll make it horizontal, and this will be 3.25. And what will be the displacement? Because this set to show the values. What is the displacement of Z? We calculate it here.
0.625.
No, that is not a displacement. That is the distance, this one. The displacement is always from the reference point. So it is 3.775. You see that this is a good question. It revises your previous knowledge of chapter 1. So this is the sketch, the displacement time. Okay. So I will send you all this. Okay. Students, have a nice time. Enjoy your weekend.